Hi, this is Prompt Engineer, and in this video we are going to be looking at shots, zero shot, one shot, or few shot inferences in the context of LLMs and in the context of generative AI. So these are the things that we will be going through. First, we're going to set up the kernel and the required dependencies. Next, we are going to summarize the dialog without prompt engineering. Then we're going to summarize the dialog with an instruction prompt, zero shot inference with an instruction prompt, then zero shot inference with a prompt template from Flan T5. Then we summarize dialog with one shot and few shot inferences. So let's start up. So let's set up the kernel. So first we're going to install the required libraries that are required. So the libraries that are required are torch here and torch data, the transformers, because we are going to be using the libraries from Hugging Face and datasets from Hugging Face. So these transformers and datasets. So after having installed that, we're going to load up the required libraries. So from datasets, we import the load dataset module. From transformers, we import the auto model from sequence to sequence LM class. From this, again from the transformer module, we import the auto tokenizer and generation configuration. So next, we need to import the dataset. So this is the Hugging Face dataset name. So this is the name of the Hugging Face dataset. Let's go to the dataset. So this is the dataset we are talking about. So this is the dialog sum dataset from KN Karthik, and here we have different splits of train, test, and validation. So essentially we have ID, dialog, summary, and topic. And if you look at the train dataset, we have ID, dialog, summary, topic. And in the validation, we have 500 rows. So we're going to use this dataset for our understanding here. Now let's print a couple of dialogues from the baseline summaries. So here, example indices, we put in 40 and 200 indice, which means in the test dataset we are going to take the 40th row and the 200 row. So here we are taking two indices, the 40th and the 200, and then for each of the indices in the example indices, this is the count and this is the index itself. We're going to print a dash line. Then we are going to put in example which is example 0 plus 1 would be the first, so example 1, and the print dash line. Then we're going to put the input dialog. Input dialog will be dataset, test, index, and dialog, which means the dataset that we're talking about here. Next, we are going to be taking the test dataset, then the index, which will be the 40th index, for example, this index, 40th index, and we are going to be looking at the dialog portion. So this is the dialog portion. So essentially we are taking this dialog string as printing out the dialog string here, and the baseline summary will be the summary here. So let's print this out and let's print this out. So here in the 40th indices we have what time is it, Tom? So I'll just search for that. So this is the one. So this is the dialog. What time is it? Person 2 says just a minute, it's 10 to 9 by my watch. Person 1 says, is it? I had no idea it was so late, I must be off now. Person 2, what's the hurry? Person 1, I must catch the 9:30 train. Person 2, you have plenty of time yet, the railway station is very close, it won't take more than 20 minutes to get there. Then this is the input dialog, and the baseline summary that we are going to compare everything is that the baseline summary is that person 1 is in a hurry to catch the train. Tom tells person 1 there is plenty of time. So person 2 is Tom. Next, the 100 index or 200 index that we are looking at is this. So here, have you considered upgrading your system? Yes, but I'm not sure what exactly I would need. Yes, you could consider adding a painting program to your software. It would allow you to make up your own flyers and banners for advertising. That would be a definite bonus. You might also want to upgrade your hardware because it is pretty outdated now. How can you do that? So the baseline summary as person 1 teaches person 2 how to upgrade software and hardware on person 2 system. Now, next we are going to load this Flan T5 model. This is the Flan T5 model. It was released in the paper Scaling Instruction Fine-Tuned Language Model. It is an enhanced version of T5 that is in fine-tune on a mixture of tasks. Now, I will bring a detailed video on what is fine-tuning and how we can fine-tune pre-existing models for ourselves, for our desired question answers or instructions. And essentially this is the paper which introduces the fine-tuned language models here. So we're going to be using the FLAN T5 here, and let's go back to the code. So this is the model name is Google FLAN T5 base, and the model that you're going to be using is auto model for sequence to sequence. From pre-train we put in the model name, so we have everything loaded up in this model. So we're going to run this. Now to perform the encoding and decoding, we need to work with text in a tokenized form, because computers need to encode the text into numbers so that they can understand. So tokenizes is the process of splitting text into smaller units that can be processed by the LLM models. Now download the tokenizer from the FLAN model by using autotokenizer from pre-train model method. Parameter use fast switches to fast tokenizer. At this stage there is no need to go into details of that. Okay, so we're just going to run this. So we're going to use an instance of the autotokenizer class from pre-trained, and we put in the model name here, and we initiated the tokenizer here. Now let's test the tokenizer. So here, if the sentence is "what time is it, Tom?" then the sentence encoded will be the tokenizer, and we put in the input as sentence and return tensors as pt. A sentence, this is the encoded sentence. Now the sentence decoded is tokenizer.decode, and the sentence encode is this. We put in the inputs ID, and skips special tokens is true. So this will be the decode statement. Now essentially the sentence decoded should be the same as the inputs that we give. So this is the tensors. So this is the encoded items. So when we say "what time is it, Tom?" then this is how the encoding looks like. It's in the form of numbers, which is pretty easy for the computers to understand. Now if you want to decode the numbers here, then we can use this part of the code and get back your original sentence that you gave. Okay, now let us explore the how well the LLM summarizes the dialogue without any sort of prompt engineering. And let's say this. So for I index enumerate in example indices. So if you remember the example indices, we put in two example indices, which is 40 and 200. So 40 and 200 rows of the example data sets will be called, and dialog will be stored in the dialog variable. So dataset test index dialog. If you head back to the dataset, so for example, if you want to store this part of the dialog, then you're going to use this dataset test index dialog, which means dataset test the index and the dialog here. So, and the summary also you're going to store in this variable summary. Then the inputs will be tokenizer, we put in the dialog here, and outputs will be the decoded of the tokenizer, decoded of the inputs. And we are going to the output will be tokenizer.decode, but not of the input, but of the model generated outputs. So this is the generated output from the model. Now we have already defined the model here. This is the model, which is Google FLAN T5, and model.generate, we put in the inputs. So this model generates this output, and that output is decoded to give you the text version of the output. So let us have a look by running this. So here we can see example 1 dash line and input prompt. So input prompt is the dialog itself. Then the baseline human summary will be the summary here. In a hurry to catch the train, this is the baseline summary, and the model generation output without prompt engineering is it's 10 to 9. Okay, now as you can see, the output generated by this prompt is very weak, and when we compare it to the baseline human summary, which is the person is in a hurry to catch the train, Tom tells person 1 there is plenty of time, then you can see that the output that the model generate is very weak output, and we certainly need to do something about it to increase the understanding of the models about the situation or the prompt or the dialogue that is going on. So let's go on. Let's look at the zero-shot inference with an instruction prompt. So essentially in the zero-shot inference, what we give is that we introduce a new prompt here. So this remains the same, I index and enumerate examples. Everything remains the same. The dialog is extracted from the dataset test index dialog, the summary is abstracted from the dataset test index summary. Input is tokenizer of prompt, so we put this prompt here, and return answer is pt. So this is the input, and the output will be the decoded part of the generated outputs from the model using the inputs, and the input itself is constructed using the prompt. So here, if you look at this example, let's see how well the model can summarize. Okay, let's compare the baseline. Person 1 is in a hurry. Tom tells person 1 there's plenty of time, and the model generated output is the train is about to leave. That is pretty good than the previous one you have seen. It's 10 to 9. So basically the situation is that it is 10 to 9, but the person 1 is afraid that that he would lose or miss that train, and person 2 tells the person 1 that there is plenty of time. So the idea here is it is coming closer. The idea here is that the train is about to leave, so that is pretty good. So this is an example of a zero-shot inference where we put in the summarize the following conversation like this. We put in the dialogue and summary, and we want the answer to come here. So this is a zero-shot instruction or prompt. Now let's go on. Let us use a slightly different prompt. Flan T5 has many prompts that are published, so this is a different prompt here. So the prompt here is that here we are putting the dialogue here. The dialogue is we put in the dialogue here, and the difference is that with the previous one we put here what was going on. So everything remains the same. We just run it, and now we expect a little better output than what we obtained. So here we obtain the train is about to leave, so not much difference. And let's look at the one-shot and few-shot inference. So for the one-shot inference, we make a function here. So the function is named make prompt, and here we give the prompt as for index in, for example here for index in example indices. For each of the example indices we go on adding the prompt here, which is plus equal to. So for first index we put in the summary and the dialogue here, and for the second index we add that too, and then we say dialogue is equal to dataset example index to summarize, and we put in the dialogue here. So the index that we want to summarize will come here, and the prompt here will be dialogue and what is going on, return the prompt. So construct the prompt with one-shot inference. So in the one-shot inference, what we will do is that, for example, example index is full, so we want just 40 indices. So we want just one indices to be given in the example indices. So here we give the 40 number indice, or if you go back to this, so we'll give row 40, for example, this row, we give this row for it to learn, and we want to summarize for the index 200. So in the one-shot prompt we just put in make prompt and example indices and example indices. So print the one-shot prompt. So if we just print it, we get this is the example prompt, and based on the example prompt we should get an output now. Now this is the prompt that is put in, so this is the one-shot prompt, but the output will be obtained now, because now we are going to generate the output. So here in the summary we put in the example index to summarize summary, and as always we take in the inputs in the form of a tokenizer. The output is generated using the model.generate, and then we get the output of the models in the output, and then we print this out. So if you print this, we will see that the baseline summary was person 1 teaches person 2 how to upgrade software and hardware in person 2 systems, and model generation one shot is person 1 wants to upgrade his system, and person 2 wants to add a painting program to his software. Person 1 wants to add a CD-ROM. So now the inference is pretty good. Now for the few shot inferences, we put in a more number of examples in the example index is full. So in the earlier case, in the one shot we put in 40, 80 and 120, but in this case we put in 3. So in the earlier case we just put 40, but in this case we put 3 examples here. An example index to summarize is 200, and we print in the few shot templates here. So there are 3 templates that goes on, and the output is generated using the same code as above. So the output will be even further good, and this shows the power of the few shot templates. So what we have done is we have initially seen that how even without a single shot, or we can use zero shot where we give just a format of the output that we want. We can use single shot giving just one example for it to learn. We can give few shots where we give multiple examples for it to learn. Now essentially what we have to do is that even if after 5 examples the solutions that the model generate is not up to the mark, then we need to fine-tune the model again. But the first thing that we can try is these 3 things: 0 shot, 1 shot, and few shot inference. And if this fails, then we can maybe go for fine-tuning or pre-training of new models, as you wish. Now, this has been inspired from our teacher Andrew, and I would like to give a shout out to him for this amazing course that I had the opportunity to learn. And as always, I will see you next time. This is Prompt Engineer signing off. Have a nice day.